We are going to be solving logarithmic equations, and we need to check for extraneous roots. Now, when we say check for extraneous roots, remember that the two conditions of logarithms, suppose that we have a logarithm, log base b with an argument of a is equal to c. Well, b has to be greater than 0, but not equal to 1. And generally, that's not where our restrictions come from. Rather, they normally come from having an argument that is greater than 0. So let's get a start on things, and it should be fun today. So allow me to look at this first question here. The log base 5 of x is equal to 1 plus log 5 base 2. So what do I look at? I look at, for restrictions, I look at where my argument has to be greater than 0. And since our argument is just x, so x has to be greater than 0. The next thing that I'm going to do, well, I'm going to collect the logarithms on both sides. I notice that they have a common base, so really I'm just going to say log base 5x minus log base 5 2 is equal to 1. In other words, I subtracted log base 5 2 from both sides. Now, this is curious, so why don't I simply put these together, and I know that this is log base 5 x over 2 is equal to 1. And this is really fantastic here. I am a little bit stumped though. So what is the next sort of algebraic move that I would need to do? So you could either do mental math here, and that would be very impressive. That would mean that you have a strong command of logs and what they mean. Or what I'm going to do is I'm going to write each side to the base of 5. And there we are. If you notice, the exponent, or our two sides of the equation, now were transformed to our exponent. So on the left-hand side, 5 to the power of log 5 x over 2 simply turns into x over 2. 5 to the power of 1 is 5. And solving for this, we get, I'm going to multiply both sides by 2, so x is equal to 10. So therefore, x is equal to 10. And once you know it, we're good to go. My restriction is obeyed. So that's one thing that we can do. So if you ever notice that we have a constant over that's isolated over to its one side, you can simply put both sides to the base of the log. And since base 5 and log base 5 are inverse functions, they cancel each other out. All right, let's move on to this lower one. So first things first, I need to consider my restrictions. So x cannot be greater than, x must be greater than 0. That's my restriction, and allow me to solve here. So I guess what I'm going to do is I'm going to use the product rule and the power of logs rule. So on the left-hand side, I would probably choose to rewrite this as log x to the power of 2. Now is equal to log 64. Pardon me, that was way too quick. I apologize. I'm going to use the product rule, so I could rewrite it as 32 times 2. The sum of two logs can be written as a log of a product of the arguments. Very straightforward now. What can we conclude here? We can conclude that x squared is equal to 64. And if we solve x squared is equal to 64, we come up with solutions. X can be equal to positive or negative 8. However, considering my restrictions, I have to conclude, therefore, x must be equal to 8. For the negative 8 would not be a solution. It would fall outside of the restrictions. All right, I think I'm having fun here. Notice, now, it might seem like magic what I'm doing, but really what I would like to do is I would like to join the arguments together. And if I'm able to join the arguments together like this one, so log x squared is equal to log 64. So on the left-hand side, there's two separate arguments. I ended up with an algebraic statement that was x squared is equal to 64. I'm very comfortable with that. So I'm able to do that. All right, let's move on. So when we take a look at this next one is kind of getting a little bit mean, I think. Wow, actually, it is getting quite mean. What do I know about restrictions? Well, over here, x has to be greater than negative 11 for this argument right here. For this argument, x has to be greater than 0. For this one, x has to be greater than negative 1. So I have a whole bunch of restrictions, but I can simplify all of these restrictions to x has to be greater than negative 11. This restriction, let's call this restriction number 1. Restriction number 1 includes restriction number 2 and restriction number 3 automatically. So really, what we have to consider, the argument x plus 11 is greater than 0 wherever x is greater than negative 11. Allow us to start. So again, I'm going to use the same trick. I have a whole bunch of logs going on. I'm going to try to consolidate my logs. And on the left-hand side, I have the sum of two logs with the same base. So what I'm going to do is I am going to use the product of laws rule. Now on the left-hand side as well, I am going to use the product of laws or the product of logs rule. And what I end up getting here is log of x plus 11 times x, and that would yield x squared plus 11x is equal to log x plus 1 times 6. So that would equal to log 6x plus 6. So what can we conclude here? Now, if those two logs are equal, this naturally implies that the arguments are also equal. In other words, x squared plus 11x has to be equal to 6x plus 6. Now, let us not forget about this restriction when it comes into play. Often what you'll see people do is to check their logs to ensure that their answer is correct. All right, so I'm going to subtract 6x to both sides and subtract 6 to both sides. And what I get is x squared plus 5x minus 6 is equal to 0. Now, factoring here, thankfully, this is nice and factorable. There we are. What I get is x squared plus 6, close brackets, open brackets, x minus 1 is equal to 0. And this yields, using the zero product property, that x can be equal to negative 6 or positive 1. Now, these are only potential solutions. I need to look up to my restrictions. You know what? And I lied. I made a mistake with these restrictions. Really, I have 3 restrictions. I have to make sure that x is greater than 0, right? My mistake. So each one of our potential solutions have to match up each of the 3 restrictions. So minus 6 can be excluded because x is not greater than 0 for minus 6. So therefore, x is equal to, there's only one solution, and that's x is equal to 1. So therefore, x is equal to 1. All right, my apologies about those restrictions. I'll try to do a better job of this next one. And maybe a better idea is maybe write the arguments as two restrictions and then compare the answers. So here, what I notice is that my arguments, negative x has to be greater than 0, or 2 minus x has to be greater than 0. Those are arguments. Now, my first restriction really means if I multiply both sides by negative 1, x has to be less than 0. Right? When you multiply both sides by negative 1, what you do is you have to flip your inequality sign. This next one here, well, I'll let you work on it. But what ends up happening is that x has to be less than 2. All right. Let's do this. So I'm going to try to combine the logs together. And what I notice on the left-hand side here is that it is the sum of two logs of the same base. And what I end up with is log base 2 of negative 2x, sorry, my mistake, minus 2x plus x squared is equal to 3. Now, notice how does this differ with previous examples? In previous examples, we had both sides have the same base for logarithms. Here, 3 is not a logarithm. So when we run into this situation where a constant is equal to one side, really what do? We write both sides as the exponent. So we write it base 2, so 2 to the power of log 2 minus 2x plus x squared is equal to now 2 to the power of 3. So in essence, both sides of the equations became our exponents. On the left-hand side, 2 and log 2 are inverse functions of each other. So really what we get is negative 2x plus x squared is equal to 8. And I'm just going to mess around with this. So x squared minus 2x is equal to 8. I reorganized the left-hand side. It's something I'm more familiar with. I'm going to subtract 8 from both sides. There we have it. Now, these restrictions are going to be very, very tricky. I know they are. But what I get is x, I'm going to factor this, x minus 4, x plus 2 is equal to 0. This leads me with x is equal to, now these are only potential solutions. I have to compare with my restrictions. What I get is x is equal to negative 2 or 4. However, I have to compare them to my restrictions. So negative 2 obeys this restriction number 1 and number 2. 4 is not less than x and it's not less than 2. And really, what you really need to do is just not observe one restriction. So 4 is out of the mix. So therefore, x is equal to negative 2. Right.